record, so I'll let it keep it if you want. Yeah, so look, we've encountered various data types, okay? The significance of all that hasn't really been obvious yet. It will grow as time goes on, and we're about to add another data type to the ones that we've seen already. So quick review, tell me one of the data types that we saw previously in this class. Yes? String is one, and those are just characters, right? And we're actually going to play around with strings just a little bit today. A sequence of characters, that's a string. Int is one of the two numeric classes that we have seen. Yes. Lists is another data type that we have seen. And lists are extraordinarily important. Lists are like the primary multi-object data type in Python. Python was constructed really to work with lists. We've got an entire chapter devoted to lists. We've also got an entire chapter devoted to strings later on as well. And then, floats, which is the other numeric data type. Now, you might have wondered, and it's a great question, right? I'm sure you'll understand why we need strings, right? And how strings are different from numbers, right? And how lists are incredibly useful. We've worked with them, right? And you need lists for the for loop that we talked about last chapter. Not strictly, you can do it without lists, but mostly you do it with lists. So the range function creates lists, so they're important. But you might have wondered, why do we need both an int type and a float type? They're just numbers, right? What significance could it have that, say, one number has no 0.0 after it and the other does? Well, we'll talk more about this later on. Ultimately, it has to do with precision. Ints are stored in such a way that they're infinitely precise. When you see the int 1, you know that it's exactly the int 1 and not some number that is merely close to it. Okay? You can be confident of that because we've done all our work with ints. Or all the arithmetic that was done to produce the number worked with ints, so it's exact. Floats are not that way. If you've got a 0.0 after something, that indicates that it's a float. And then all you can assume about it is that at best it's approximately equal to that value. And there are contexts in which it makes all the difference in the world, whether it's just approximately equal to or exactly equal to. Did you notice that in the range function, you couldn't use floats? At some point along the way, did you notice that if you tried to put a float into the range function, like 33.0, the range function yells at you and says the float object cannot be interpreted as an integer, that is, I wanted an integer. Why would Python care about that? Because it doesn't want merely approximate values to construct ranges. It wants exact values. We'll talk more about that later on. There are dangers that involve the use of approximations. It's inevitable that you have to sometimes use approximations, but there are dangers involved. Anyway, so those are the data types we've seen. Today, another one. I tell you what, since I'll record this, I've decided to record it. I'll just type a little bit in the code editor, just words I would like you to see. The data type that we're about to consider today, begin to discuss today, is the Boolean data type with a capital B, because it's named after someone. George Boole, B-O-O-L-E. You can look him up if you want. He was an English logician, mathematician in the 19th century, who was really the first to investigate the matters that we're about to discuss today. Okay, and they're ultimately logical matters. This is broadly part of logic that's been recruited in computer science to perform a very important task. Okay, so we'll talk about the Boolean class. Or maybe before I actually launch into that, I'll give you a sort of hint at where we're headed with this. Probably good to hear that. Okay, so back in chapter 1, right, we wrote just a program. That's what you had to turn in, right? And when you hit the run button, the program executed from top to bottom, right? First line, second line, third line, and so on. You exercised no control over the order in which those lines of code executed, okay? Now in chapter 2, where we learned about functions, you did have a kind of control over order in which lines of code execute that you didn't before, right? Because you could write a function, and then initially, the body of that function wouldn't execute, but you could call the function, that is, make it execute with certain input values, and then, the body of that code would execute. And you could do it again, right, however many times you wanted. So you had a measure of control over, which chunks of code execute and when. And then obviously in the previous chapter, the last chapter, over iteration, you had another kind of control, right? With for loops. That is, you had the body of the for loop, and then that body would execute from top to bottom once, and then maybe again, and then maybe a third time, and so on, right? So the flow of control in that case was under your control. Now, there's another kind of way to change flow of control. Okay, that is the order in which the lines of code are executed, and that's called selection, and that's what this chapter is about. And roughly the idea behind selection is this, is you perform a test, and then the outcome of the test tells you whether you will execute this block of code or perhaps another block of code, or perhaps even no blocks of code at all, okay, of an associated set of blocks. You perform tests, and the outcomes of the test tell you which code to execute. Okay, that's what this is about. Well, we really do need another data type for that, because we need a data type for the outcomes of these tests, okay? And that is the Boolean class right there. Oh, in the Boolean class, it's special in a number of ways. One way in which it's special is that it has two and only two members, which, if you compare it to the other classes that we have seen, is quite extraordinary. Like, how many ints are there? Don't know, potentially infinite. I guess not actually, because your computer does have finite memory, but lots. How many floats? Lots. How many strings could you construct? Lots. How many lists? Lots. Again, it's difficult to pinpoint exactly what the limit would be, I suppose there is one eventually, but it's huge. The Boolean class, 2, okay? And let me show you what those objects are. Oh, and remember something about the console. If you type an object into the console and Python recognizes that object, that is, it knows of the existence of that object, it will simply repeat it back to you. So, yeah, it said 2. Okay, an expression like that is called a literal. That is, if you type it into the console and Python simply repeats it back, in other words, says, yep, I know what that is. That's a literal expression. Well, let me show you another one. Capital T true. This is the first member of the Boolean class. If Python knows this object, it will repeat it back to us. I don't know why I get 2 instances of the prompt, something with the internet connection, don't know. And then also capital F, false, okay, capital F, false. Notice the capitalization, okay? It is absolutely essential in this case. If you were to type in lowercase t true, don't hit return yet, okay? Part of what it means to learn Python is to learn what Python will do, is to learn to predict what Python will do, okay? So, what will Python think that lowercase true is? I'll give you a hint. It's not the Boolean object, okay? So what will Python think that this has to be? Variable, okay? And then have I assigned a value to this variable? No, so Python will yell at me and it will say something like, I don't have a value for that name. There it is, name true is not defined. And the same is true for lowercase f false as well. Yeah, so the 2 new objects that we wish to discuss today are the capital T true and the capital F false, okay, the 2 Boolean objects. Now, what I wish to show you today are how to build up expressions whose values are Booleans, that is, whose values are either the true or the false. And that's how they're often spoken of, with the definite article the in front. Again, the true and the false, and that's how I'll often speak about it. Okay? So, expressions that evaluate to a Boolean, either the true or the false. Well, I mean, you know roughly what I'm up to here, right? It's like, whoa, that's an expression, very simple one. And if I hit the enter key, it evaluates, okay? And the value of that expression is returned. It's the same language here, okay? We'll have expressions. They will evaluate, and then the value that will be returned is a Boolean, okay? Is a Boolean. And you can probably, oops, that's not what I wanted. You can probably begin to make guesses about this. So there is a Boolean valued expression. That is, after I hit the enter key, the value of this expression will be printed to the screen. The value does belong to the Boolean class that has only 2 members, true and false. So what is the value of this? You would hope that it is true. Otherwise, Python is hopelessly broken. So, yep, that is true. How about that? Excuse me, let me do it the other way around. How about 2 less than 1? That should be false, right? There we go. Okay, so those are comparison operators, not all of them, but what do? They take comparable objects, compare them, and then return a Boolean. And you don't have to use just numbers, right? So, So I'll just go ahead and throw this example in. Potentially you could use them. Actually, you can use them to compare strings as well. Python can make sense of this. So it says that that is true. Any guesses? This actually will be useful in a number of contexts. Anybody have a guess about why Python would say that this is true? Initially, you might think it's a little weird. Yeah, it's alphabetical order. That is alphabetized. And then if you do, ABC comes before DEF. Now, here's a curious little fact that I'll acquaint you with already. So what if we were to compare the lowercase and the uppercase? Oh, apparently that's false. So that means that if I switch the direction of the comparison operator, it should turn out to be true. That is, apparently, from Python's point of view, capital ABC comes before lowercase abc when you alphabetize. And actually, that's not just some quirk of Python. That's the way that this is universally handled. So here's something you can look up if you want to. ASCII table, the ASCII table. It depends upon the uppercase and lowercase their position in the ASCII table. And the ASCII table is old. It's much older than computers. It goes back all the way to, I think, like teletype machines or, like Morse code typed in, So you can go look that up. We'll come back to that at a moment in time. But the point I did want to make is that these comparison operators, they work across different classes. Yeah, of course you can compare numbers, but you can also compare non-numbers as well, and we definitely will. Now you can probably figure out what that particular expression means. We'll go quickly through the other comparison operators. What do you think should be the truth value of that?
Wait,
Yeah, what do you think that will evaluate to?
One is less than or equal to 1.
It's less than or equal to. Okay. So that should be, is 1 less than or equal to 1? The or equal to part. But yeah, it's one or the other, right? So how about 2 less than or equal to 1? And again, less than or equal to is less than symbol followed immediately by equal symbol. So that should be false, of course, right? And again, you might complain. It's like, all right, Python, why did you choose a new symbol for this? Why not use the symbol that I'm accustomed to with mathematics? And the answer is, look at your keyboard. Do you see that symbol there? The only symbols that will ever be used in any language that will ever be constructed, at least for the foreseeable future, are ones that are standardly available on a keyboard. And that symbol is not there. If you wanted to cause a great worldwide revolution among all the programmers where they just would simply insist that they never program again, make them write in some language where they have to do some weird keyboard key combination to get characters. Okay, it would cause civilization to fail if you were to try something like that. So yeah, there's the decision, and that's more or less, I think, universal among computer languages. That's less than or equal to, and of course, this would be greater than or equal to. So is 3 greater than or equal to 3? Indeed. Is 2 greater than or equal to 3? Nope, that's false. Okay. So we've got less than, greater than, less than or equal to, greater than or equal to comparison operators. We would also, of course, like to have equality comparison, right? That is the expression on the left equal to the expression on the right? Now, there'll come a moment in time where we'll have to worry about what precisely that means, because Python can actually do this in more than one way. But for us right now, the comparison operator that we want is the one that is double equal sign. Okay, that's the comparison operator. Equal sign, nothing in between. So this, think of this as a question, perhaps. Is the number 3 equal to the number 3? True or false? Presumably it's true. So is the number 4 equal to the number 3? That presumably is, before it was true, now it is false. Okay, now it is false. Here's a mistake that you will make. Okay, there will be some place in your code where you intend to do a comparison, right? Indeed, you'll intend to do the equality comparison, but you'll use just the single equal sign. I still do it with regularity. When you begin to think about like sort of what your code means and don't really focus so much on the symbols, it's very easy to do that. What will Python think you mean if you use a single equal sign? Because that's what Python always thinks you mean when you use a single equal sign.
Reassign the first value.
Yeah, variable assignment. Okay, but that will likely have happened in a place where variable assignment was not possible, so you will get an error message, and you should now understand that you need to read your error messages. Okay, very often your error messages will tell you in a simple case like that what's gone wrong and you can fix it. Okay, so comparison for equality. It would also be nice, of course, to have a comparison for inequality. This asks the question is for unequal to 3. And that is the exclamation point followed immediately by the equal sign. And that will be, of course, true. It is true that 4 is not equal to 3. And it is false that 3 is not equal to 3. Okay, it is false. Now, again, to the question, why doesn't Python use the usual mathematical symbol for inequality, which is the equal sign with the slash through it? It ain't on the keyboard. Okay, that's why not. So you have to use some other option. And I always imagine that in the case of Python, the reason why they chose the exclamation point followed by the equal sign is that visually it looks a little bit like the equal sign with the slash through it, about as close as you could get. Maybe not as close as you can get, but it doesn't matter. It's still, that's what that means. Okay. So those are comparison operators that allow you to build expressions whose values are Booleans. There are 3 other, and these are called logical operators, 3 other ways that you can build expressions whose values are Booleans. And these are, I'll tell you what, I'll put it over here as well. These are and or, and not. Okay, these are the so-called logical operators. And what the logical operators do is they take Boolean valued expressions and return Boolean valued expressions. Like the operators we've looked at so far, like the less than operator, that could take numbers, okay, like 2 less than 1, and return a Boolean. It would return the Boolean false in this case. But and or, and not, they take Boolean valued expressions and they return Boolean valued expressions. And it's really very natural how it is that they work. So how about this? So let me assert that 2 is greater than 1 and 3 is greater than 2. That's a complex expression built up from comparisons, 2 greater than 1 and 3 greater than 2, by means of the logical operator and. And what do you think the truth value of this complex expression should be? That is it true that 2 is greater than 1 and 3 is greater than 2? Indeed, that is true. Okay, so I'll go ahead and hit enter, and we'll see that that is true. But one must think about this the way that Python does. Okay, the way that Python thinks about this is, well, okay, so complex expression. So let me go and evaluate the parts, and then the values of the parts will be used to get the value of the whole. Okay, so 2 greater than 1, true or false? True. 3 greater than 2, true or false? So here's what Python saw after partial evaluation. Okay, it saw true and true. And the logic of and is that both must be true for it to become true. If either is false or both are false, then it's false. So what Python saw as a kind of intermediate stage was true and true, which is true. So how about this? So how about if I tried this case? So 2 greater than 1 and 3 less than 2. Well, the first comparison, 2 greater than 1, is true. The second comparison, 3 less than 2, is false. Okay? And again, the logic of and is that both must be true for the whole to be true. But in this case, not both are true, which means the value of this expression should be false. And of course, if we were to make both false, so 2 less than 1 and 3 less than 2, well, we need both true for the entire expression to evaluate to true, but neither of them is true, so that has to be false as well. Okay, so that's the logic of and. Now let's talk about the logic of or. And I tell you what, I'll go up and I'll just make alterations in the lines that we had previously. You remember the arrow keys, right? They can move you through the previous lines of input, which is enormously convenient. So how about this one? 2 greater than 1 or 3 less than 2. Yeah, that's fine. We'll do that one. Or. The logic of or is that at least one of those is true. Is at least one of those true? Yeah, the first one, right? So if at least one is true, the entire expression will evaluate to true. And of course, if we were to go all the way back to this, which is what I intended to do initially, and put an or in between, that is 2 greater than 1 or 3 greater than 2, well, both of those are true. So at least one is true, of course, which means that the value of the entire expression is true. And if I were to flip the directions of the inequalities on both, so 2 greater than 1 or 3 less than 2, well, both of those comparisons are false. So Python sees false or false, but it will say true to an or statement only if at least one is true. But in this case, we don't have at least one true, so that will be false. Okay, that will be false. Now, let me show you some more complex examples of the sort of work that you can do with all of this. Okay, the kind of tests that you can perform to give you a sense of what kind of work we can do with all of this. And this is like really new. The kind of work we'll be able to do in this chapter we absolutely could not have done with what we have discussed so far. So if you haven't seen this yet, you've seen it now. You can assign multiple values to multiple variables. Well, you can assign values to multiple variables on a single line of code. Simply separate the variables by commas, and then on the right side of the assignment token, separate the values that they will get by commas, and then of course it goes by order. So A will get the value 3, B will get the value 4, C will get the value 5. Yeah, and it works beautifully, right? So A is 3, B is 4, C is 5. Now let me do a complex comparison. The way this brings together work that we have done throughout the entire year. So here's a complex expression that involves the variables, okay? So let us think about this the way that Python would think about this. Well, first of all, it would substitute in values for variables, okay? So instead of A, we would have 3. Instead of B, we would have 4. Instead of C, we would have 5. And then Python would continue on. And then it would have to square A. Okay, so what is then A squared? That would become 9. And what is B squared? 16. And then it would perform the addition, the 9 plus 16, which would give us 25. And that's what's on the right-hand side of the comparison operator double equal sign. And then on the right-hand, that's the left-hand side. Then on the right-hand side, we have 5 squared, which is 25. So look at what has happened. On the left-hand side, we get 25. On the right-hand side, we get 25. And so Python then has the Boolean expression 25 is equal to 25, and it will declare true. It will declare true. So do you know the geometrical significance of the comparison we've just done? What kind of triangle is this? It's a right triangle, okay? It's a right triangle. Now let's do another set of values. I'll do these and we'll be done. So let's do a D and an E and an F. And let's assign to them 5 and 12, and how about 14, okay? 5 and 12 and 14. And then let me do the comparison like I did before. So D squared plus E squared, does that have the same value as F squared? Oh, we can see. False, it does not, okay? So what do I know about a triangle with side lengths 5 and 12 and 14? It is not a right triangle. But here's a follow-up question. And you'll actually do this work in the function set. Here's a follow-up question. Well, if it's not right, it's obtuse or acute. So which of the two is it? Well, actually, the answer to that depends upon another comparison. So let us ask whether D squared plus E squared is greater than F squared. I mean, it's not equal, and that's one of the two possibilities, right? Oh, well, apparently that's false. So I think we have now deduced that it must be less than, but we will verify that. Oh, indeed, that it is less than. Oh, so actually we've determined something about a triangle with side lengths 5 and 12 and 14. And what we have determined is this. It's obtuse. It's obtuse. You'll see this in the function set, okay? So can you begin to sort of get a sense of maybe what you could do with this? You know? I mean, I'll show you actually how to use the Booleans that result from this kind of work to make decisions about which, of associated blocks of code to execute, okay? So we can like test and determine whether our triangle is right or acute or obtuse, and then, we can, what we do with it will depend upon which kind that it is. And that's something that you could totally do in this chapter. All right, so I think we'll stop there. Those are the Booleans, and then next time I'll show you what you can do with them, how you can take control of the order in which your code executes in a way that you couldn't have done before.